Assalamu alaikum dear students, welcome back to my channel. In last lecture we discussed some operations that can be performed between two sets or more. Those were union, intersection, relative complement, complement and symmetric difference. Today we are going to talk about binary operations that are operations which can be performed between the elements of set, or you can say which are defined on some sets. Also, we will discuss some preliminary concepts from number theory that are required in the proper study of group theory. So let's start. So first of all, we are going to talk about a binary operation. Let us define it. A binary operation steric on a set S is a rule, or you can call it a function or mapping, that assigns to each pair of elements of S another element that might be same as those two operating elements, or might be one of those two elements of S. That is, for all A, B belongs to S, for any two elements that you take from S, you perform operation steric between them and you get another element of the same set S that as I have already mentioned might be one of these two as well. Okay, so this is what we call a binary operation. So let's take some examples. Usual addition, that is binary operation on set of natural numbers, set of whole numbers, set of integers and set of reals. So this is a binary operation. By the way, unary operations or those operations which acts on single elements. For example, if you take conjugate of a complex number, you don't need two complex numbers, you just need one complex number and you will apply the conjugate operation on that and you will get your required answer. Okay. Another example of binary operation is on a set of positive integers. We define steric as A steric B, which is equal to A. Okay, as I have already mentioned that when you operate the steric operation between two elements of a given set, the answer might be one of those elements. Okay, that's quite possible, that's not a big deal. Alright, ladies and gentlemen, the next few concepts that we are going to talk about are from number theory, and as I have mentioned, these are very important for proper study of group theory. Let's talk about the first one. It's known as division algorithm, or sometimes it is called Euclidean algorithm or Euclidean algorithm. I have no object with the pronunciation, that's up to you. So division algorithm or Euclidean algorithm is stated as: let A and B are any two integers where B is greater than 0, meaning B is positive. Then there exists unique integers Q and R with the property that A is equal to B times Q plus R, where this R is greater than or equal to 0 and is always less than B. Okay, this is the division algorithm that we use in our earlier classes, but we are not explicitly told there about division algorithm. By the way, if R is equal to 0, and we will talk about this R very soon, if this R is equal to 0, we say that B divides A. This is a notation from number theory that suggests that B is completely dividing this A. Okay, now let me tell you what is the name of A here, B, Q and R. Okay, so here A is called a dividend, B is called a divisor, Q is called quotient and R is called remainder. Okay, so here we have an example. Let's say A is equal to 17, B is equal to 5. Then by Euclidean algorithm or division algorithm, you can say that 17 is equal to 5 times 3 plus 2, where this 17 is a dividend, 3 is quotient, 5 is divisor and 2 is your remainder. And now, ladies and gentlemen, we are going to talk about the greatest common divisors. Simply we write it as GCD, or it has another name as well, and that is highest common factor, and we use HCF for that. So what is this? The greatest common divisor of two or more than two integers non-zero A and B is the largest of all common divisors of A and B. Okay, it is denoted by GCD, and then you include those two elements whom GCD you are taking. GCD is sometimes called HCF, which means highest common factor. I have already mentioned this. So what is this? You write the common divisors of those two integers a and b, and out of them the one which is greatest, which is largest, that is known as greatest common divisors of those two integers, those two non-zero integers a and b. Okay, so here we have example for that. We have been asked to find the GCD of 12 and 16s. As we know that the common divisors of 12 and 16 are 1, 2 and 4, and out of these three, 4 is the largest one, so we simply say that the GCD of 12 and 16 is 4. Okay, and on the basis of this definition, we have another definition, and that is of very importance, especially when we will be studying the cyclic groups. That will be quite important. So what is that? It's the definition of being relatively prime or co-prime. Okay, so what does it say? I have written it here as a note. So if you take GCD of two non-zero integers a and b and your answer is 1, that means the greatest common divisors of those two, the greatest common divisor of those two non-zero integers a and b is 1, meaning that there is no other integer greater than 1 which can divide both of them. So then if this happens, then a and b are relatively prime or simply co-prime to each other. This is quite important in the study of cyclic groups. Keep this in your mind because this will be used later on. The next result that we are going to talk about is one of the most fundamental and most important theorem, or you can say result of the number theory. Okay, so it is known as a fundamental theorem of arithmetic, and it's very simple. Its statement is very obvious, very clear. It says that every integer greater than 1 is either a prime or product of primes. Okay, now this is very important result for number theory as well as for group theory. When we will study the fundamental theorem of finitely generated abelian groups, then you will know its importance. It is used there extensively. It has so many applications in many other branches of mathematics, but since we are talking about group theory, so we will definitely use it in many other concepts, but the most important of them will be the fundamental theorem of finitely generated abelian groups. We will talk about that later. So the product is unique except for the order in which factors appear. Okay, if I write a number using fundamental theorem of arithmetic, if I factorize it, let's say I have 24, so we will factorize it. 2 12 times 24, then we have 2 6 times 12, then we have 2 3 times 6, and then 3 1 times 3. So 24 is basically equal to 2 to the power 3 cross 3, or you can write it as 3 cross 2 to the power 3. So this line is actually saying that this expression is unique up to the order in which factors appear. In other words, you can write this on this side or this on this side, that will not matter at all. Okay, on the basis of this, we are going to define another term, and that is known as the least common multiple, or simply LCM of two or more integers. So now this is a very important concept, and we will use this when we will talking about permutation groups and the orders of permutations. We will use this. Okay, so keep this in your mind as well. So what is least common multiple? The least common multiple, or LCM, of two non-zero integers a and b is the smallest positive integer that is a multiple of both a and b, and it is denoted by LCM of a and b. Okay, so what is this? Let's say you have two integers, one of them is 4, the other one is 16. Okay, so write down the multiples of 4. Multiples of 4 are 4, 8, 12, 16, and so on. And the multiples of 16 are 16, 32, 48, and so on. Now take the common between these two. 16 is the first number that is common between these two. Okay, and it is the smallest positive integer that is divisible by both 4 and 16, or you can say it is the smallest positive integer which is multiple of both 4 and 16. So the least common multiple of, let me write it here, the least common multiple of 4 and 16 is 16. Okay, Here we have another example. If you take the LCM of 4 and 6, you know that the multiple of 4 are 4, 8, 12 and so on, and the multiple of 6 are 6, 12 and so on. So 12 is the smallest positive integer, which is multiple of both of 4 and 6. So LCM of 4 and 6 is 12.